Hello everyone, welcome to another video with Maths with Sarah. Today we're going to be looking at this question. So it's an algebra question looking to find an intersection point between two lines. Again, as with all of these questions, it's towards the end of the paper, so it's question 18 out of 21. So it's kind of looking at their grade 7 plus type questions. So not necessarily an easy question, but I would like you to just take a few seconds, maybe pause the video and have a little think about how you would tackle this question. If you can do the whole question, that's great. Go ahead and just use this video to check the answer. If you don't think you can do the whole question, just have a think about what method you would use, maybe what you would start by doing, and then pop back in a few seconds and I'll go through it with you. So hopefully you're all back now. Now I'm going to go through how I did this question. Now there are, as with all of these, a lot of these questions, there are probably multiple ways of doing it. This is the way that I would recommend, and it's most likely the method that you'll have been taught at school, but there are multiple ways of doing it. So the first thing that we need to kind of think about is that we've got two lines. So we've got line 1 that passes through points, and we've got two coordinates for those points. And so if we start by working out the equation of line 1. So to do that, we're going to use the y equals mx plus c equation. So hopefully you will remember that in this case, the m is the gradient of the line, and the c is the constant, so i.e. how much it's moved in relation to the origin, either up or down, up for positive and down for negative. So we've got two different coordinates, and that will allow us to calculate the gradient. So the gradient, or m, is calculated by doing either, I've heard this in a number of different ways, so either rise over run, or difference in y coordinates over difference in x coordinates. So if we look at the difference in y coordinates, we're going to have 6 minus 2 on the top of the fraction, and then on the bottom we will have the difference in the x coordinates, and this will be 4 minus 12. And if we work that out, you're going to get 4 over minus 8, which will give minus a half when simplified. So we've worked out what m is, so we can substitute that into this equation. And then the last thing that we need to do to work out this equation of line 1 is to find out calculate what c is. So to calculate the constant, we need to substitute in one of this coordinate. So remember, this coordinate is made of the two values, the x and the y coordinates, and we can substitute each of those values into this equation to give us the value of c. So if we use this coordinate, you could use either of them. I'll make that clear. You can use either of them. Just for it being the first one, I'm going to use this one. So if we put in the y coordinate, we're going to get 6 equals, and then I'm going to use brackets just to make it really clear which bits which, times by 4, which is the x coordinate, and then we'll have that as plus c. So we're going to get 6 equals minus 2 plus c, and that's going to give us c equals 8. So we can now rewrite this equation with the equation for line 1, which is y equals minus a half x plus 8. Okay, so we found the equation of one of the lines. Hopefully you were able to follow what I've done, or had a go at doing it yourself. So the second part is we then also need to find the equation of line 2. Now this one is quite a bit simpler, and because we know that it passes through the origin, and the origin course, is the coordinates 0, 0. So it has no, the y coordinate is 0 and the x coordinate is 0. So if we write down y equals mx plus c again, we know, we've been told that here that the gradient is -3. So we don't need to calculate m. So we've got -3x plus a constant plus c. Now, if we substitute in a value of y and x equals 0, then we'll end up with 0 equals 0 plus c. So that suggests that there's no value of c, i.e. there's no constant. And if we think back to what we know about graphs, we know that if a graph passes through the origin, that means that it's not got, it would normally just be something times x. So it's got a gradient, but no constant to kind of move it up or down the y-axis. Okay, so we've got to this step. We probably at this point will be getting at least 2 marks, if not possibly 3 marks for this question. So well done if you've got to this point. So the last part is looking to find the intersection point in this. They say that the lines intersect at point P. So we need to find those coordinates at point P. And the way to do that is we're going to make sort of a somewhat simultaneous equation. So we know that where these two lines intersect, the y coordinates and the x coordinates are going to be the same. So we know that whatever this y equals, this y also equals the same. And therefore we can set both equations equal to each other. So in order to find what x is, we'll do -1/2 x plus 8 is equal to -3x. Okay. And now if we add -1/2x, just add 1/2x to each side of the equation. Remember, what we do to one side, we also have to do to the other side. We're going to end up with 8 equals -2.5x. Right. And then to work out what x is, we're then going to do 8 divided by -2.5, which is going to give you -16 over 5, sorry. Notice that I'm just doubling each of these to make it so that the fraction has whole numbers in it. Just it's not good practice to have 2.5 as the bottom of a fraction. So at the denominator of a fraction. So now the next step is to find out what y equals. Now, just for the sake of ease, I'm going to substitute this x value into line 2, the equation of line 2, purely because I don't really fancy trying to times this x value by -1/2. I'd far rather times it by -3. So in that case, we know that y equals -3 times -16 over 5. And that is going to, remember, if you times 2 negatives, you're going to get a positive value. So that's going to give you +48 over 5. So your coordinates, just for finishing off this question, the coordinates of point P are an x value of -16 over 5 and 48 over 5 as the y value. Now, obviously, you could convert these to decimals, and that would be just as right. Personally, I prefer to leave it as a fraction, but in the mark scheme, both answers as a fraction and as a decimal are considered correct. So don't worry if you had converted it to a decimal. Now, for me, if I was looking at this question, I would probably be doubting myself and thinking that this can't possibly be the right answer, because you would normally expect to have whole numbers. It does look a bit of a nasty answer. It looks like the sort of question where you probably made a mistake somewhere. I can assure you that this is the answer that's in the mark scheme, and this is the right answer, and we can verify that by putting either of these numbers back into one of these equations just to confirm that it is correct. And if we did that, we would get the answers. The answer, it would suggest that it is correct. So hopefully you've been able to follow that follow that through. Hopefully if you're feeling a little bit more confident about tackling this style of question. Don't worry if you weren't able to do it without my help. But hopefully you now have an idea of at least how to start solving these equations. So even if you might struggle to get the full 4 marks, hopefully you would be at least aiming to get 2 or 3 marks now. So just want to say, please subscribe to the YouTube channel so you get notified straight away whenever I post new videos, and make sure you like it as well. Comment if you've got any topics or questions that you particularly want me to answer, and I hope to see you again at the next video.